Good. Cool. I guess just to do a quick recap, even though last class I think we are mostly just downloading processing mostly. So you should have processing installed on your laptop now. But just a quick recap. In processing, we talk about sketch rather than process like a program. So basically, whenever you see a sketch, it's not like a sketch for program. It's basically a program in processing. Sometimes it's a bit confusing, but it's also good when you are Googling for it, just say processing sketch, blah, blah, blah. Then you will get something better results from Google search rather than just something about process. Oftentimes you get something about multi-processing, which is a headache. But anyway, processing will have the full IDE, which is very nice. You have a text editor, console, and display window. But over the time you will get a sense what it's like. So this is like our first processing sketch. Just to quick recap, size will create the 400 by 400 canvas, and then you can draw a circle, which pretty straightforward. And it's just X, Y diameter, and you have a bunch of other shapes. And we talk about color. So most likely, usually you're using RGB or hex code. So basically, if you just put in a number, think about it, this number is just basically the same for RGB channel, and that will give you a grayscale. You can also do RGB color. And if you're grabbing colors online, usually you get hex code. There are tons of website for palette selection. So usually you just copy paste the hex code. Sometimes it's much easier. And you can also enable HSB color, hue, saturation, brightness. This is especially helpful when you want to change the color, like a rainbow effects. Then hue would be a good way to do it. You just need to set a color mode to HSB before you use the color. And we talk about this, rectangle. One thing different from circle is that circle you use the center point as the anchor point, but for rectangle, by default it uses the top left corner as the anchor point. So if you want to set rec mode to center, and remember that it's O cap for center. We will get to that today. And rec mode, the M is capitalized. This is what we call camel case. Should be straightforward, camel case. So some lowercase and uppercase for to just let you easier make it more readable, basically. More shapes, circle, ellipse, basically just square versus rectangle. So they have the exact same sort of parameters set up. You also have point, line, triangle, and quad. Should be very straightforward. So we look at this, even with just these, we can actually already just create this, block M by just combining all these shapes. So likely we won't do it now, but you can look at this code. It's very messy because you have to calculate where these knots, where their XY position is. So this is likely not the best way to do it, but anyway, even with just simple shapes, you can already do that. Just a bunch of the circle, the rectangles, and two quads. Then you can do this M shape, block M. Cool. So today we will talk about more stuff and should be more fun. Like at least at the end of the class, you should be able to do this. The creepy eyes, very fun. So let me grab the slides. Cool. So we'll just dig deeper into processing. But again, likely just still scratching the surface of processing. But that could give you a bunch more tools that you can use. Cool. So first, more on shapes. So, we talk about this block M thing, and you likely notice if you want to do it, you will see some borders, some outlines for all the things that you draw. So the first thing is that, to get rid of the stroke, you can just use no stroke to get rid of the outlines, and stroke weight to set the outline weight, and stroke color to set the outline color. So let me just pull up processing. Whoops. So, then so let's first create a bigger canvas, make it larger. Cool. And then we just draw a circle at 200, 200, and then 100. And you can press Command R or Control R to run it. So you will see that there is the outline. So to get rid of the outline, no stroke. Remember that it's camel case, so S need to be capitalized. Now hit Control R again. Now the stroke is all gone. So if you want to set the stroke weight, you can also make it, thicker. But at the same time, you can also just use stroke for a specific color, say, Haskell FF 0000. What's that color? Black. Nope. S code is like so RRGGDB. So FF 0000. What's that? Yeah, full red. So F is the maximum value you can get. It's 15. So again, like 0, 1, 2, 3, 4, 5 to 9, and then A, B, C, D, E, F. So these are 10, 11, 12, 13, 14, 15. So F is the maximum value you can get. So, this will give us full red. And by full, let me make it. Stroke weight 5. Yeah, so this full red. And so, if you want to get G green, this is not the typical green, is the, RGB green. So very bright green. And then if you want to get full blue, then you get 0000 FF. So to get white, you want to mix 4 RGB together. So OF, you will get RGB. So it's gone because the outline is the same as the color. And if you do O0, you will get black. Yep, but easier if you want to do grayscale. Usually you just send in a number. So 0 to 255 will give you the grayscale. So this is a much easier way to do it. So 50 will be 127 will be gray in the middle. So this is gray in the middle. What else? And you can also do, so there's so sometimes you see just 3-letter hash code. So sometimes you see something like this. Oh, it's not supported here. Anyway, sometimes on the internet, you will get some hex code that's just only 3. But whenever you see something that's only 3 code, say FAC, that basically translate to FFAAC. But it's not supported in processing anyway. But sometimes on the web, you will see people, using hash code as 3-letter. Basically, you just repeat them each for RGB. Cool. So basically you can get rid of the stroke. So now, no stroke, then no outlines. If you have the stroke weight 3 set to, RGB, so R full, R 255, 0 for green, 0 for blue, then you get for red, and you will get this outline on that. So, this is the way how we create block M because we are, mixing up a bunch of different shapes. So you will see the outlines. And you want to get rid of the outlines to get the block M, then you need to do no stroke. But there's also another way to do it. This is something called custom shapes. So you can do begin shape, and then you just start it for all the vertex. So, for this, it's just going from 60, 100, 60, 160. So again, X go from left to right, Y go from top to bottom. So 60, 100, now you go 60 downwards because you increase Y, meaning that you are going downward. 61, 60, and then 80, 160. So stay at the same level of Y value, but now you increase X for 80. So you go ahead and then get all the vertex. So this is another way to get the constant shape, but at the end, you need to make sure that you close it. So N shape close. So if you don't do it, you will get something like this. So when you have the stroke, the outline, you will see, it's missing one final segment because you didn't actually going back. So once you get it close, it will get the final line connecting and close the curve. So you might wonder why this could be helpful, but in the future, perhaps, you are building a special shape that's much harder to compose by just using geometry. Geometric shapes like triangle or rectangle, then this picking shape could be helpful. And you can also write it as a function that you can just say, well, we define a function that's block M and then show all these things. And then you can pass block M everywhere on your canvas. Anyway, this is the way how you do custom shape. Cool. So that's like a detour. But one thing you will probably notice is that how we actually write this code. So one thing you will notice, the difference between this and that is there are something weird going on here. So there's the void setup and void draw stuff going on. And that's what we are usually be coding in processing, the way how we code in processing. So we have the first function. We will talk about what is a function. But for now, think about it as two different part of the program that we need to execute it differently. So typically, we have this setup and draw. This is like predefined function in processing, and it will be called when the program starts. You set up the sort of like the canvas, the setup, the environment, and then you start drawing on top of that. So the idea is that, well, setup will only run once when the program starts, and draw will run every frame, and default FPS is 60. So what's happening here is that, you set up a canvas. So you set up a 400 by 400 canvas, and then you no longer need to do it again and again. It doesn't make sense if when you are drawing, like a game or doing something, your canvas will change over time. If that's the case, then, you can put it into the draw so that your canvas change over time. But most of the time, you set a canvas and then you start programming on top of it. So this setup, size 400, 400, will only be executed once. And then the draw function will be executed again, and again, just like, how the computer is making all the animation that it will change over time, and do this again and again. And the default frame per second is 60. So think about it like, you are actually creating not a static program. You are creating an animation. You're creating a game. You're creating a video that's over time, it's keep updating what's going on that you write in the draw function. So we have this simple example. Let's just write it this way. Void setup. For now, just do it the way it is. And we will get into it later. 400, 400, semicolon, void draw. background so that we set the background. Oh, the color doesn't look right, but should be more gray. Anyway, and then we will talk about, I think we've talked about this. Mouse X and mouse Y will get the current position of your cursor, where your cursor is. Okay, cool. So this is the program that we have on the slide. So now if we hit Control R, you get this. So basically, what we are doing is that we set up this canvas 400 by 400, and then that's it. The setup will only be executed once. And for this draw function, it will keep doing it again and again. And that's why you see whenever I move to another position, now my cursor is here. So it will set the background as 50. So you see the grayish. The color is not perfect, but it should be anyway, background 50, more gray. But circle, mouse X, mouse Y, 10. So you will get a small circle here. So I can also make it larger. Yep, so a larger circle. Cool. So you get a sense. That's why you can control it, and it will be updated every time. So what happened if we move the background 50 to set up? Any idea? You can always just do it yourself, but think about it. What happened? Try it. So now you get this. So why is that? So what's happening here is that, well, now you move the background here. Now background is only executed once when you start the program. So, when you hit Control R, when you run it, you set the background as 50. So you get this, grayish background. And then this will be called again and again when you move your mouse around. But you didn't clear you didn't reset the background again and again. So you will leave the tracks. So this is, very helpful, especially for some of the generated arts that we showed in the last class that, you can leave the trace, and you can even set up, fade out trace for some of the past stuff. So you can always, apply a layer, like a transparent layer, so that things in the past will get fade out over time. But at the same time, you can just keep it around. So, that's sort of give you a sense that what setup and draw is doing. So for draw, it will be called again and again over the time with your specified FPS, frame per second. So by default, it's 60 frame per second. And once you move the background here, then the background won't, be called every time. So everything will be there. For this case, you call the background thing. So, all the past circle will be covered by the background 50. Cool. So we will get into that more, but these are just two specific functions that's already predefined, and we will get into what a function is. But anyway, for now, think about it like something that processing already defined for you, and you can just use it. And some of the simpler task or art can be already created. Even you can even create a game by just using these two. So you can also control the draw function. You can do no loop, you can do loop, you can do frame rate. So let's do no loop and see what happened. So you have to put it in the setup. So if you do no loop, you will see that nothing happening. So no loop meaning that, well, the draw function will be called again and again. So that basically just stop the program somehow. But you can also set the frame rate. frame rate to say 1, so 1 frame per second. So now it will be very laggy. It will just update every second. So very, very laggy. I guess it's a bit confusing, but frame rate 10, it will be much laggy than the by default frame rate 60 per second. Cool. So that's the way how you control the draw function. So what is a function exactly? So you can look at this thing. So definitely you will see this void thing that's look terrifying. But void, null, nil, all sort of these words in programming, all and none. They all corresponding to something specific in programming. That's just nothing. That means nothing. So in Java, you have all, in processing, you have void, and in some other language, you have null. And sometimes you also see nil, nil. And in Python, it's none. What else? I guess these are the 4 most common one. But all of these basically mean nothing. So what's going on here is that, well, we have the function name code setup. So you can code setup, but this is built-in function. So it will be code at the beginning of the program. And it doesn't take any parameters because this is the first thing you run in your program. So it shouldn't take any parameters. And you need to sort of like wrap everything inside it with curly brackets. That's just the syntax so that, the function knows that, well, everything between these brackets are the content of this function. And finally, the most confusing one is the return type. So some of the functions, think about it like, I don't know, square or square loop or, draw something. Sometimes, you write a function, you want it to return something. So think about square, you want to enter 2 and it will just square it for you. So become return 4. And then you have a function that's square 3. You want it to return a 9. So sometimes you want some return from the function. But in this case, this setup is just throwing something and set up the canvas. So it doesn't return anything. And in processing, nothing basically is represented by void. And also you will notice that you can also write some comments, but basically those are just comments that provide others and a way to understand your code. So this is very straightforward, size 400, 400. So most of the time people won't write comments, but it's always a good practice to write comments. And of course, in the assignments, write as many comments as possible. It's good over the time, not just for for others to understand what your code is, but at the same time, a year later, you come back to the same code. Sometimes happen to me. It's like, what the hell I'm doing last year. So it's also good to keep the notes so that you know what's going on. You're right. Cool. So that's a function. So this is basically what we have. And you can write all sort of function. We will get into that later. So why functions? We will get back to this, but for now, it's very hard to see why we should do functions. Why shouldn't we just write everything without all these functions? We just write everything. So there are some benefits of it, and over the time, you'll get a sense why these are important, and that's why people are writing code in a specific way rather than just having top-down process that just write everything without writing the function. So one thing is about modularity. You can always copy paste part of the function that you can reuse in another project. So think about you write a function that can paste block M. And what if you are doing a game that you need a logo at the bottom right in multiple projects? Then you can copy that function into other projects. So that's one thing, modularity. If you don't have that function, oftentimes you have to, figure out where it is. And it's much easier to copy paste and, reuse them. Oh, yeah, that's the reusability. So for modularity, I guess it's more on making the code into more readability, more understandable with self-contained modules. But also readability. So think about this. This is a function in processing that's called distance. So distance x, oops, typo, x1, y1, x2, y2. Yeah. Anyway, let's just take it away. X1, y1, x2, y2. So this should be self-explainable, just basically two point, x1, y1, and x2, y2. And this function will basically just show you the distance between them. And so you just put into x1, y1, x2, y2. And what it does is basically just doing square root of x1 minus x2 times x1 minus x2 plus y1 minus y2 times y1 minus y2. But look at the readability, like the right one, you have to stare at it, and at some point you'll realize, well, it's still calculating the same thing, it's just calculating the distance in a different way. So this is just an example, but always write the function with a clear name and some comments about what it actually does, so that it's much easier to read. And finally, scoping. We will get into this. This is very important, but for now, you likely won't get the sense why it's important. But avoid variable name pollution. We will get into that later. Cool. So now we have another built-in function, which is very fun. Mouse clicked. So it will execute whenever the mouse is clicked. Can be handy in many ways. Resetting the whole canvas in an interactive session, but also if you want to take screenshot for your assignments. So let's look at this. We can have an example. Let's do this. So this is the example where, we will leave the trace. But what if we want to build something that, whenever we click it, and we just get rid of, clear the whole canvas. Think about it like a pent program. So what we can do is that now we write this built-in function, void mouse clicked, no input, and return nothing. So void mouse clicked. And now whenever we code this function, then we set background to 50. So it should clear everything. Okay, does this run it? So let's actually make the circle small. So well, you can now draw something, and whenever you click the mouse, everything will be gone. Because whenever you click the mouse, it will run this part of the program, and it says background 50. So everything will be clear. So just this very simple built-in function. You don't necessarily need to write a lot of stuff. Now you can create sort of like a program that could be interactive in the most basic form. And so, you can also do that what I show on the slides, where you can do save frame and set the name of the file. This will be helpful, especially when you want to, save a screenshot in your assignment. So you can also do save frame, I don't know, example.png. Oops, oh, got the semicolon. So, now you draw and you like it, and then you click it. And now, oh, I have to save it. Otherwise, it doesn't know where I am. So, oh, yeah, this is something I should also talk about. When you want to save a sketch, it will save a folder rather than a single file. So let's take this, for example. Well, it looks very bad. Let's just go somewhere. Just get a temp folder on my desktop. And then I would just save this, my processing sketch. Cool. So now I should be able to find it on my desktop. So now I can see it on my desktop, like temp, my processing sketch. So again, it's a folder. So you could also see the thing that I just say, temp PNG. And if you get another name, another try, then now you draw a different shape and then you click it. Now you will see that being saved. So this is very handy, especially when you want to, um, you know, take screenshots for your assignments. Cool. So that's mouse click. And of course, there are a lot more, like mouse press. Mouse is pressed. So you press it and then you release it. Then that's called mouse clicked. So, press is when you push down the button, release when you release it, like tap it up, lift it up, and then click, meaning that the full operation of press and released. And you also have mouse moved. That's just, your mouse is moving, but dragged is when you being pressed and then you move around. So well, now we can try to get this example. So you can basically create a pen function, a pen program just by doing this. So what we want to do is that, well, when you do mouse drag, you can draw something and then you click it, it will clear everything. That's, I sort of like spell it, but let's try to do it. Cool. So what do we need? So for setup, let's just clear everything. So two goals. One is that when we click and not click, press and drag the mouse, we want to draw the circle. I have caps lock on. Mouse drag. Cool. So in the draw function, we don't really need to do anything, so we can just leave it alone. So whenever mouse is dragged, we want to, draw a circle where the mouse is, mouse X, mouse Y, and then 20, maybe 10. And to avoid it to be too ugly, we get rid of the outlines, so no stroke. So this should already give us something that we can do. So nothing happened because in the draw function, there's nothing. So, you set up the canvas, you set the background to 50, grayish. But for the draw function, the one that's being, called again and again, it's nothing. So nothing happened. But now for this function, mouse drag, whenever you drag the mouse, it will start drawing something at the position where you have your mouse at. So now if you press it and then draw something, then you can get these. You want to try it? Cool. So now to reset it, we want to get mouse click. And so the easiest way to clear everything is just to set the background again, and that will just override everything you have. So now if we have mouse click background 50, it should be able to get rid of everything. So let's just rerun the program a bit. Again, you can press escape to end the program. I always hit escape, then we will get that. Anyway, if you press Control R, it will run again. So now you can drag and then click to get rid of it. So this is sort of, very simple pen program that you can do with just mouse dragged and mouse clicked. Cool. Questions? Nope. Should be fairly straightforward. So that's one thing I like about processing. It's so easy to get started with, and then you can already do a lot of stuff without digging into a lot of the details. And you have a lot of built-in functions that's very handy, especially for creative coding. So, mouse drag, you draw by pressing and dragging the mouse. That's what mouse dragged mean. And then, mouse click, you just clear everything by just calling background 50, because that will reset the background and overwrite everything on top, beneath it. Cool. And there's also like keyboard functions. We will talk about it in next class. Keyboard is a little bit more complex because, for mouse, there's just 2 buttons. So most likely you're just clicking it, pressing it. But key, you need to know where you are typing. So key press is like any key is pressed. Key release, any key is released. Key typed, the key is clicked, code repeatedly if you held down. So if you press it and then don't release it, then it will keep running this part of it. So these are just one of the way that you can detect, keyboard inputs. But next slide, we will talk about how you actually detect which key is being pressed. It's a little bit more complex. Cool. Questions on functions? Nope. Cool. So next is about variable. I guess we'll just talk about it, and then you will see in real example, that's when you realize why we need that. So if you want to define a variable, variable is handy in all sort of case. You will see in the assignment. But basically you want to declare it and then initialize it and use it just as in any program, most likely. So you declare what this function, what's the type of that is. Float is just saying any numbers, any numbers, not just integers. So you have, I think the most important 2 category of numbers is integers. So it says 1, 2, 3, 4, 5. But float is any numbers that, it could be 1, it could be integers, but it could also be, 1.2. numbers with the point. So float is basically floating point, meaning that you could have decimals. Cool. But there's another way that could be handy in some case that you can declare and initialize at the same time. You just do float x equal 200, and then you can use it right away. You don't need to initialize it again. So you would also see the difference between declaration, initialization, and use in this case. So setup is where you initialize stuff. And draw is when you use stuff and then you use it again and again. And declare is at the outside. You think about what these variable is. You want to allocate some of the memory on your computer to remember that, oh, we are going to use this x. It's a number. You need to allocate some space so that you have a dictionary where you can look up for that number. And you can always declare and initialize at the same time. Cool. So, this float is just the data type. We talk about, integer, float. There's a bunch of other types. We will get into some of the other more complex ones, but these are the most basic one. Integers, 0, 1, 2, but also negative ones, -2. Float is anything, both numbers. It could be 0, 1, 2, -1, -2, but at the same time, 0.0, 1.5, 3.14159. 2.71828. And the other one is Boolean. This is also a very important type, which is basically just yes, no, or 1, 0, or true, false. So in processing, you need to use true, false, but basically that's just a switch. Think about it. So examples is like, well, usually integer, you would use count. So, over the time you want to count what's going on. For flow, it's usually, some numbers, say what's the speed of a ball that you are developing a game, where, the mouse is. Boolean, usually for state or status or, flag of indicating a switch. So think about it's game over. We will use it in the first homework. So you can say false. It's not game over yet. And once the game is over, you set it to true. Then at that time, things will be different because once the game is gone, it's done, or it's game over. Then you want to stop the whole program, sort of, or pause the program for some time. Again, camel case is scan over. That's much easier than everything lowercase. Cool. And there is likely, you notice that we talk about width, height, mouse X, mouse Y, and there's a bunch of other built-in global variables, and that's why we can use it without defining it. So, mouse X and mouse Y, these are just built-in variables. It will get updated automatically in processing, but these are special variables that's already been defined so that you don't need to, say, integer mouse X, and then you can use it right away. That's not because they are not defined. They are defined, just hidden in processing, already defined before the program started. And also like rec mode, this center scene, OCAP, meaning that it's a global variable. It's also defined. You also have mouse pressed. So this is a Boolean. This is a Boolean. So yeah, for now, I think it's very hard to show that without talking about conditions, but we'll get into that later. Cool. Now we have our first exercise, creepy eyes. You might be surprised that we can already do it with everything we just talked about. So first thing you want to do is to start with drawing this static face without the eyes moving. So just draw something that's, on the background color, whatever color of the face, draw a circle, and you want two eyes at some place, and then you want a smile. Or if you're don't feeling happy today, you can make it another place. And for the smile, you can use arc, and I already computed here. So the arc thing here is that this is X, Y, width, and height. And then 0 pi is where you draw the arc. So basically is that, the center is 200, 200. And we are not, this is like an ellipse that has the width of 50 and then it has the height of 20. And now an arc is not the full ellipse. It's just go from 0 to pi. So in processing, we go from this is 0, this is pi, this is half pi, this is 1.5 pi. So basically you go from 0 to pi to draw this arc. Anyway, for now, just do this and you will get that curve. Cool. Just do it, I guess, to get the face. So I will also write something here. Oh, pi is a predefined global variable. Whenever you use a global variable that's predefined, it will become pink color so that you know it's already defined. Yep. So this is what I can get, just, a circle and the arc function with this. And yeah. So just to explain a little bit more on the arc. So 200 to 220 is where the center is. The width is 50, the height is 20 for the whole ellipse. And now you go from 0 to pi. And so if you want to do the other half, now if you want to get the set face, now you can do, minus pi. to 0. Now you get a sad face. So minus pi is, going backward. So this is pi, or this could also be minus pi. So minus pi to 0, or you could do pi to 2 pi, which is kind of confusing, but that's how we do the angles in processing. So pi to 2 pi. So every single point has multiple numbers. So 2 pi and 0 both represent the right hand side. The bottom is half pi. This can be called by half pi. Anyway, just use 0 pi. Cool. Have you got the ice correct? I don't know. It's whatever is 180. Not bad. Okay, now I got a base. You're good. Feel this. Um, you've got the face. Now what? Now you want to get where your cursor is. So now basically what you want to do is that say let's take the left ice X example. So this is left ice, which is at 180, 180. And now you have your mouse somewhere here. This is at mouse X and mouse Y. So what you want to do now is that you want to move these things a little bit further away toward that direction. How do we do that? First, you need to know how far away is your original eye position toward the mouse position, and then you want to scale it into, say, 0.1 times, or divided by 10. So that's how we kind of do it. Yeah, so that's exactly what we want to do. So more hint. So what we want to do is left eye X and left eye Y. And now your goal is to, instead of doing this, instead of doing circle 100, 100, now you want to calculate this by something. And then you want to calculate the left eye Y by something. And then now you want to draw it at that position. Oops. Okay, so that's more, hopefully much clearer. So now your job is to figure out how to get this. Are you trying? Cool. Any progress? Done? Nope. Any idea? Cool. Um, so the so again, just looking at this, what you want to do is to see, how far away your current x, 180, and the mouse axis. So this line would be mouse x minus 180. And how about this? Now you want to move the original eyes to slightly away from that. So divide this by 10. And then, add the original position back. You should be able to get the new position x. And now do the same for y. Then you can move the move the eyes to the correct position. In programming, at least in processing, how you write this is to do this, or you could do times 0.1. That's how we write. So this means divide, and this means multiply. So basically, you want to write this thing or this thing. Cool. Any successful attempt? Cool. And so basically, you just repeat that for all the other part. So let's just try for the x and y. It's the same. Now you want to do mouse y. Somehow keep typing in minus 180 divided by 10. Yeah. Oops, there's something over there. What's going on? Oh. Did I do something wrong? Why is there a point there? I think we are right. Just there is some point over there. Let me rerun it again. Why are we getting that? Second I isn't. Oh, I mean that's the right circle. I was wondering where. Oh, I forgot to reset it. So I need to move this background thing. That's the previous circle, and then okay, that's a very nice example of tracing. So now if I put it here, then it was gone. So what happened just is that because this background thing is outside of draw, um, it's outside of draw. So what happened is that, well, when we start the program, um, my mouse is outside. And so whenever my mouse is far away from that, it actually just throw it at that corner and it will get erased because I didn't do the background. So that's the previous eyes that just move outside the face. Anyway, this should be the correct way to do it. Cool. So now the left eyes will move and basically want to do the same for the left eyes, the right eyes. So right eye x equal to 220 plus copy paste. Now this would be 220. And then you do the same for y. So right eye y. Now it's 180. That's the original position. And then now mouse y minus the original position, 180 divided by 10. Now you don't want to do the fixed one. Now you want to do right eye y and right eye x. And we have to define these variables because, right eye x does not exist. That's where we need to define it here. So you could just do right eye x and I y. Sometimes it's very messy to do this. So one way to do it is that you can actually define multiple by using a comma. So oftentimes we just group them, left eye x, left eye y, right eye x, right eye y, but this will define two variables, both with type float. Cool. So now we have the left eye. And the right eye. Cool. Yep, that's it. Oh, good. Cool. So as simple as that, it's just some calculation and very simple. Just doing calculation without even actually writing any functions. You can already do that. Cool. So yeah, I mean, this is an animation of that. So you have mouse X, mouse Y, left eye Y. This is the way how we write it, but a better way usually is that you can also set, the original left eye X. You set it to 180 and you have the original left eye Y to 180. You have the original right eye X. So this way you can offer, some flexibility on resetting the position of your original eyes. Just that now you need to replace all of these with the original left eye X. Replace everything here with original left eye Y. And then same for the other eye. So, now you can define more variables. That comes with the benefit that if you don't like the position of the eyes, then you can just move it around. I mean, if you want to make it lower at the center, it might look a little bit weird, but let's see. Now, the center become lower. I messed it up. Cool. So now you can make the eyes in lower. place, position. So, these are the benefit of variables. So the way how we are using it is just to, these are variables that you will be using in the function. So you don't initialize it because at the beginning, you don't know what those are. These are, variables that to be set by the user, or, sometimes, if you want to execute a program, you want to have controllability. So these offer you some customizable numbers so that you can, change over time, so that, whenever you want to have a different design, maybe you add a eye blow or, hairs, then potentially you want to move the eyes positions, then these variables will come into handy when you want to have that flexibility. Anyway, so basically you have left eye X, left eye Y, mouse X, mouse Y. And what you want to do is just to calculate how far away you want to do that. And this is the way I typically do it. I mean, you just calculate how far away the delta is. So delta means like how much difference between the X. And that is mouse X minus left eye X, and divided by 10, same as time 0.1. So you just do it and then write it. Cool. So, simple as that, we can actually already do a very interesting, tiny, interactive program. Questions? Nope. Surprised on how simple that is. Yeah, I think that's the beauty of processing. It's like, you can already create something with it's just the simple, I don't know, less than 20 lines of code. Cool. So next we will go into conditionals. So this is basically if else. Maybe you heard of, or very straightforward. If something, then you do something. So this is the way that you can offer some flexibility of your program, or control the routing or the execution ordering or process, or the whole overall flow chart. So usually we look at this as a flow chart. So when we do the program, we just go and then check for the condition. If it's true, then we do something. If it's not true, then we just skip that, and then we just don't execute that. And if it's false, then we just jump without executing anything in between this block. So sometimes you want to set it differently. So this is if else. So if the condition is true, we're going to do something, and then you will have else right after the if. Notice that the syntax is a little bit different. So if the two brackets here, that's the intersection of if, that's what something will be executed here. And then else, another pair of curly brackets. Let's do something else. So whenever that condition is not true, we will do the other things. Straightforward. So this is like some examples, flow X equal 100. So this is initialized as 100. So, if you have like this block of code, if X is smaller than 200, in this case, yeah, X is 100, so it's smaller than 200, then you fill 0. So now it become the color become black. So when you draw the circle, you get a circle, a black one. But now, if you set the X to 300, now this doesn't true, no longer holds. So now it won't execute this field 0. Instead, it will go into the else block and execute whatever that's inside it. And here is a field 255. So you get a circle with a white color. And the position also changed because your circle is at position X. Cool. So that's the basic one. You should be very straightforward. It's just look at it. You should get a sense of what is going on. But for relational operators, we talk about smaller than. Of course we have greater than. We have greater than or equal to, less than or equal to. But more confusing is the equal to and not equal to. So for equal to, you have to use double equal sign. That's because whenever the function, the program see equal, they tend to interpret that as x equal 1, this equal. So this equal is different from, if x equal 1. So it could be confusing for the program. So that's why in lots of programming language, we tend to use double equal sign to indicate when we are trying to verify whether this is true or not. And the other one is not equal to. That's basically this thing, but this guy doesn't exist on your keyboard. So we usually just use exclamation mark plus an equal sign. And so exclamation mark, usually in whatever language, it basically says no. So not even just like not equal to. Sometimes you will see, say if is game over. So we talk about, the something. So we talk about the Boolean function. So you can set, it's game over to true or false. So this is like, if it's game over, then you do something. But what if you want to do something when it's not game over? So this is the case where this exclamation mark can help. So whenever you add the exclamation mark in front of some Boolean variable, it will just negate it. So now it becomes, if not game over, then you do something. So basically, whenever you see exclamation mark in programming world, it usually just say no or not, or, negate everything, Cool. So these are likely the two that you need to be careful of. And, these other things are very straightforward. Cool. So that's the second exercise that we can do. The class ended at 4:30, right? We got 10 minutes. I think we can hopefully make a good progress on this. So this will be the homework one, but it won't be due in 2 weeks, so don't worry about it. So what we want to do is, this bouncing ball. So basically you just need variable, and if else conditional, then you can do this. So to start with, let's do this. Never stopping ball. Likely just try to copy paste that. Yep, this is a sketch. Load x equal to 100. That's where the ball started. And we will have load speed x. That's the speed of the ball. We set up size 400. Cool. Void draw. That's the main function. Background 0 or 50, whatever. Okay, now the magic's here. If you want to move the ball, so for every single frame, you just move the x position of the ball for, add 5 to that. So if you do this, it would basically get a ball and then we're just gone. So what's happened here is that, well, we have a ball that's originally started from x equal 200. And then, it will start at x 200. And then, we would do this x equal x plus speed. So in the first run, it's like 200. So whenever you run this, it will be 200 plus 5. And then you will use this new number to replace the original x value. So now x become 205. And the next one, when you executed this, x plus speed now become 205 plus 5. So now you update x into 210. And then you go from 210 and plus 5. Now you get 215. So that's how you just move this ball. by just calling this draw function. Remember that this draw function will be executed again and again at frame rate 60. And so basically this will just give you never stopping ball that just escape the screen. Because at some point your number will be larger than 400. And so it still exists, just that it's gone. It's somewhere here, and just long gone. So your goal now is to see when should we make the ball bounce back. And to make it bounce back, now you want to change the direction of the ball is moving. So originally it's x plus speed x. So somewhere here, you want to make it into -5. So that the ball now is like x plus -5. It will bounce back. So how do you do it? It's not that. It's a little bit tricky. So just do it, and then likely it will stuck somewhere there, and you will get a sense why it's so tricky. Just try something. So the idea is that if x is outside of this part, you want to change the speed into the other side. Cool. Any failed attempt? It will likely fail in the first try. There's no way you can get it right in one shot. So the most basic one, well, if current x is larger than 400, that's where the boundary is, then we change the direction. Speed x now become -5. Let's see what happened. Capital X. Oops. Okay, it bounced back and it no longer comes back. So, what now? Yep. So now if x is, that's where the tricky part comes in. And once you look at this, you will get the sense why it's so complicated. Okay, let's try this. It will be very fun. What happened? Oh, if x smaller than 0. Yeah, let's do it. I think this will just make it work. Cool. That's it. So there's a lot of details happening here actually. If you do this before these things, it might not work. Well, it does work. Okay, I forgot what's the nuance here. Anyway, this basically just make it work. So whenever x is larger than 400, you just turn that speed into -5. And then if x is smaller than 0, you just turn it into the other way. Oh, I think oftentimes when you start program this, sometimes you would do this. Because you have the speed x, which is 5. So you sometimes just like, well, I just do the negative sign. And this won't work. This actually work. So why doesn't work? I forgot. But anyway, this is another way to write it. Yep. Cool. Everybody get it on? Cool. I think we're running out of time. And I forgot what I want to say for that thing. It just worked somehow. Anyway, so that's the thing. Oh, I see. What's the point? So you also have to take care about the bowl size. So what we just write, it actually will, you know, bounce into the wall. It will sort of like sink into the wall. If you look carefully, I mean, let's make it larger. 50. It actually just bounced into the wall. So if you want to take care of that, you need to, you know, make sure that it's, half the size of the bowl. Yeah, so that's the trick, so that it bounced at the right position. Other than that, that's it. So that's the first. Second exercise. Initialize bowl position, check if the bowl has hit the left and right corner. If so, then you just turn the speed, reverse the direction that the bowl is moving. And then you move and draw the bowl. So this is usually how you do it. And so for homework one, even though it looked a little bit different, but basically you want to do the same thing, but now it's in 2D case. You want to do this hollow word, and I was sending instruction by emails, and it's already available on course website. But basically the goal, we've covered this in class that, you can do X, then you can definitely do Y. It's the same idea. But the tricky part is that you need to know how to do text rendering, but also how to calculate the size so that it won't, like the bowl case, it will sink into the wall. And so the goal is to help you to understand how to, get a sense, explore how you can figure out those by looking into the documentation. So documentation is your friend. Take a look on that and use it to draw this. Cool. And yeah, for the assignment, there's also in the homework instruction, you need to create a GIF. So this is built-in not built-in technically. So go to tools, manage your tools. We'll show that here. It would have this, and then you will find under the tools tab, you will find this movie maker. So you have to click install. I've already installed it, so I could have it here. And once you install it, there will be a movie maker here in the tools. So that should work. Once you click it, if you are on Mac, most people likely on Mac, then you can just do it. You choose the folder where you save all the frames. We have the sketch that will save the frames. You set the frame rate to 30, especially for GIF, you have to set it to 30 because GIF doesn't do anything larger than 30. And then you choose the output file, then you can get the GIF. That's how you get the things to upload. And for Windows, you have to do this because there's a bug. Unfortunately, I think the developers are all using Macs. That's why Windows doesn't work. But just do this and you should be able to do it, because I'm also using Windows. So use this, then you can do it. Cool. Other than that, see you next week. Next Monday is off. So see you next Wednesday.